Okay, obviously I can't. Alright, what'd you get for a sign?
Half a second.
Half a second. 0.65. 0.66. 0.72. Point what? 7.1. Okay. Okay. You're still in their data, so you need to say it loud because she's taking your data.
Half a second.
Half a second, 0.5. 0.6. 0.67. Okay, sounds good. Let's see how accurate your measurement is. We have actual theory to work from. This is where the calculus comes in. Record your time there. Now, to check what it should take by the actual theory. Now, again, I'm sure you have some kind of crazy physics formula, blah, 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 whatever. I don't ignore, forget, leave it alone, leave it at the door. Okay? We are going to talk where those formulas that you memorized come from. Calculus. Here we go. The acceleration due to gravity. You should know 2 facts about acceleration due to gravity. I have no doubt that you know the metric version, negative 9.8 meters per second per second. Yeah? In feet, you're talking negative 32 feet per second squared. That makes sense. About 10 meters is about 30 feet-ish. You know what I mean. So, in this case, we're going to be using negative 32. Our goal is to get a height equation based on that one calculus fact. Now, I know that acceleration is negative 32. From that, you should be able to find velocity. What is the velocity relationship to acceleration? Is it the derivative or the antiderivative? It's the antiderivative of acceleration. Actually, let me write that, then the numerical. So velocity is the antiderivative of acceleration, which is the antiderivative of negative 32. Acceleration due to gravity on Earth is a constant. Okay? When I antidifferentiate, what is the antiderivative of negative 32? Negative 32t, and the minute I integrate, I get a constant. Now, you're actually going to get 2 constants, one for velocity and one more, and you get height. So call it c1, just to differentiate, because those constants aren't going to be the same. How do I find that c1? Yeah, I need an initial condition. I need to use an initial velocity condition. What is it? At that ceiling, did you throw it down? Did you throw it up? What did you do? You dropped it. So what's the initial velocity? 0. Okay, because it's dropped via 0 at time 0. That implies then that 0 equals 0 plus c1. That first constant is 0. Okay? Therefore, your velocity equation is just negative 32t, no constant. You with me?
Yes.
Okay? Now let's go on to position. What is position's relationship to velocity? Antiderivative of velocity. So I'm going to differentiate negative 32t with respect to time. What's the antiderivative of negative 32t? Negative 16t squared plus a new constant. I'm not going to call it x. I'm going to call it h. X is ridiculous. That's horizontal motion. Am I right? Okay, so let's call it h or y. Do you have an initial condition? Oh, actually, I told you. I forgot to tell you. Hey, the ceiling in this room is 9 feet high. So, what's the initial condition? At time 0? Yeah, at time 0, height is 9. So that tells you that 9 equals 0 plus c2. So from that, obviously, c2 has to be 9. So your height is negative 16t squared plus 9. Track it. Now to answer the question, how long should it take for it to go from the roof to the ground? Well, if I want it to hit the ground, if I want when it hits the ground, then what do I want to use? H is 0. If it hits the ground, that implies H is 0. If negative 16t squared plus 9 is supposed to result in 0, then that would happen at time of what? Now, at this point, it's awkwardly long how long this is taking. So what is it? 3/4. Yeah, 3/4 of a second. So, those of you who ever had 0.73, you were the closest. It should take 0.75 seconds. Obviously, we have some measurement error in there. All right? That is the process of the day. Now, notice in the work, in essence, I expect you to show 8 things as you go from acceleration all the way down to height. I need you to show me the calculus relationship of velocity to acceleration. I need you to show me what the antiderivative is. I need you to show me what initial condition you're using to find the constant, and then you're showing me the velocity. You're reporting this is my velocity equation. Then you do that same thing for height. Show the integral relationship. Find the antiderivative. Use the initial, find the height. Nowhere in those 8 steps does it say, just use recall from physics and say the equation for height is this. You'll show the calculus. And I'm not talking tonight. I'm talking every homework problem you do in this class, you will do it that way. Okay? So, I think these are all out of order. Let's go this one. Okay? A ball is thrown straight up, released from a point 5 feet above the ground. Ball reaches a max height of 69 feet at time 2 seconds. Find the equations for velocity and height using calculus. Do you feel like you know enough to do this yourself, or should we walk through one together? Okay? You should start with the acceleration due to gravity. The acceleration due to gravity is, now, it's either negative 32 feet per second or negative 9.8 meters per second, depending on the units of this problem they're working with. In this case, they're working with feet, so we're going to use negative 32. The velocity is the antiderivative of negative 32. So the velocity is negative 32 t plus a constant. Says it's released, thrown straight up. Thrown straight up probably means that the velocity at time 0 is positive, but it doesn't say how fast it was thrown up. So I'm not sure how to find that. Oh, actually, maybe I do know how to find that. Is there something in there that would tell you how to find that C1? Read carefully. Extract some kind of, now it's not obvious. You have to kind of make a deduction. Yes? Okay, I like what you're looking at, but I don't agree with 69. If it's at its max height, at this point, time is 2 and height is 69. What's velocity? 0. Okay, at that instant, velocity is 0. I can use those two guys together to find C1. The velocity is 0 when time is 2, which implies C1 is 64. Now that probably means, doesn't probably mean that, means the initial velocity is 64 feet per second when it's released. So the velocity equation is negative 32t plus 64. Are you tracking? All right, now this is basically 2 halves. There's one getting velocity and one getting height. Now I'm going to work the height equation. Height is the antiderivative of velocity. You could write it as the integral of v, or you could write it as the integral of what you found for v, as long as you write one of the two. Take the antiderivative. What is the antiderivative for height? Negative 16t squared plus C2, okay? Now, to solve for C2, we would need a time and a height. What is the time height condition we have to work with? 69 feet at 2 seconds. So height is 69 when t is 2. From that, we have to do a little bit of arithmetic. Oh, actually, yeah, well, maybe I was working too hard. So C2 is 5. Maybe I could have actually used a different addition condition. There are really two height conditions. One was at time 2, height is 69. What else? Yeah, a ball is thrown straight up from a height of 5. So maybe a better condition would have been used at time 0, height is 5. Yeah, wouldn't that have been easier to work with because time 0 and all? That said, the height equation is negative 16t squared plus 64t plus 5. Did we answer the question? Yes, we have the equations for velocity and height. Now, physics people, especially UAP physics people, it's tempting for you to write this. Velocity is negative 9.8t plus the initial. And for these problems, that's actually true. That constant will always be the initial velocity. The problem, and I want you to not do that, I want you to use calculus and call it a constant of integration, is because that idea is not true for all types of motion, just motion due to gravity. And so I feel like if you just use good calculus, you'll be good in every situation, not just this situation. So my point is, when you integrate, I want you to call it a constant, not the initial. Understood? Okay, try one on your own. Every time Wile E. Coyote was my favorite cartoon. So every time I see this, I think Cal Hobbs. So, well, should we use, let's go metric here. Would you use metric this time? It doesn't have anything in it, so I'm just going to ask. I'm missing one. Charlotte. You use for your initial velocity condition. Time 0 velocity appears or seems to be 0. It feels like he's just falling. He's not jumping up. He's not jumping down. He's just falling. What should I put in here? So the equations you would use to model what's going on while it's in the air would be 100% equation we have in there. The graph, yeah, it's just, so I understand the first thing. Really, that's not just using just before that. So instead, 0. Okay, I totally understand what you're saying. Yes? Okay. So, what's a height time condition you have? Height is 0 at time 7. So if you put that in, what is C2? A positive 50 times 7, 350, 343-ish or something? Is that, are you with me? Am I 240? Negative 240.1? Okay. Positive 240.1. All right, do we agree? So the height equation is negative 4.9 t squared plus 240.1. How high is the cliff? Well, how would I answer that? How high is the cliff? Doesn't he start at the top of the cliff? So what time is the height of the cliff going to happen? Yeah, times 0, height is 240.1. So that 240.1 meters, that's how high the cliff is. If it took him 7 seconds to fall, it must have been a 240 meter cliff he fell from. You follow? Okay. That is that. You could probably do some off the homework, or should we go to questions on old homework? Old homeworks. Okay, what do you have here? The fun sheet. Would you get out your fun sheet, which is blue? Yes. And a grading pen, please. Let's drop a 9 on this baby. Grade it in an AP way. So, there we go. All right. Okay. Okay, for A, where's F prime? Is F prime, use the graph of F prime to determine if F is concave up, concave down, or neither on the interval. What did you say? F is concave down. F is concave down on the interval 1.7 to 1.9 because Y, here's F prime, 1.7 to 1.9 is here-ish, because Y. Alright, so to get F double, don't you agree that concavity is about F double? Yes. Okay, and F double is about the slope of F prime. So you would say F is concave down on that because F double, which is equal F prime slope, is decreasing? Slope is negative. Now If you said decreasing, you're actually doing another possibility. Another possibility is to say f prime, which equals f change, actually, f prime is negative. You could say it this way. So I'm trying to remember how it's also said. F double is negative because f prime is decreasing. That's the same as saying f prime slope is negative if you say f prime is decreasing. Yeah? So either one of those is good. Give yourself 1, basically give yourself 2 if you answered it correctly. If you said f prime is decreasing or f prime has negative slope, and that implies concave down, then you get 2 out of 2. B. Use the graph and where the graph is concave. That's A, dum-dum. Find the value of x for its absolute max. Okay. So, what did you start with? EVT, yes. F has an absolute max. Absolute extreme, but does it just say max or max? You could say extreme or max, depending. If it says specifically just max, then either way. At an endpoint or a critical number, or right? Cool. Then you need to show where the critical numbers come from. Critical numbers. If you just reported, that will not get you the point. You must clearly say you understand where critical numbers come from. So you can't just start cranking out stuff. Where do critical numbers come from? F prime is 0 or undefined at. Now at that point, feel free to use your calculator. The derivative zeros are here and here. You might have occurred to you, geez, I could have found those mentally. Does this ever equal 0? No. What makes this 0? When x squared is 0 or pi or 2 pi. So your actual zeros are 0, square root of pi, square root of 2 pi. I don't know if you probably recognize them from your decimal forms, but if you had either those or their decimal forms, whatever they might be, those are your critical numbers. Cool? For x or decimal approximations. All right. Now, we have our candidates. We have 0 is really an endpoint. The endpoints are 0 and what, 3? Okay, is that right? Yes. Okay, so, great. I have candidates, 4 distinct candidates. 1, 2, 3, 4. I believe that 2 pi is in the interval. So, how do we find the amounts at each of those? F at 0 is given, I guess. F at 0 is 5, right?
Yes.
How do you find all the other candidates? Yeah, you gotta use the fundamental theorem, either in 2 steps or 1, but the fundamental theorem says the value at f of square root of pi is f at 0 plus the change from 0 to pi of f prime, right? And did you get something like 5.679? Wait, okay. I'll be interested in those of you who had Miss Cannon last year. Did you find f at 2 prime or did you blow it off? You found it. Okay, now it's okay to blow it off, but with justification. I'll explain that in a minute. Let's just find it. F at 0 is, or f at root 2 pi is f at 0 plus 0 to square root of 2 pi f prime, oops, of x dx. And did you get something like, what did you get for that one? I don't have that in front of me. Actually, did I? 5.407? 408? I had 4077, so 407 or 408 is good. And f at 3 is the integral using limits from 0 to 3. Did you get something like 5.5789? Okay. All right. Just a second ago, I paused and said you could blow f at 2 pi off. Why is here's square root of 2 pi? Why could that be removed from the analysis? Why could you dump that? Yeah, it's a min. You can see the derivative's going negative to positive there. Well, you're never going to get an absolute maximum or relative min. That's ridiculous. So you can leave some candidates out if you like, as long as you justify why. So if you didn't have this, or you didn't decide to find it, then you would say, but not 2 pi because f prime negative to positive. Now at the end of the day, it's almost as much work to justify why you're not doing it as actually doing it. So I just do them all. It's up to you though. Okay. If you leave a candidate out from your analysis, you must say why you did so. So we conclude that the absolute max is. Do they want where the absolute max is or what the absolute max is? Find the value of x. And so, which one is the biggest, by the way? This guy? So do I answer 5.679 or square root of pi? Square root of pi. The question asked, at what x value does the max occur? So you'd say the absolute max occurs at x equals square root of pi, either because it's the greatest of the candidates, or you say, hey, 5.679 is greater than 5.578, which is greater than 5.407, which is greater than 5. So either that, that's your answer. With me? Your points. Your points are 3. Did you identify the endpoints and the critical numbers correctly? That's 1 point. Okay? 1, did you show the work to find the F values, the fundamental theorem work behind it? You can't just, if you just reported without showing this, that won't do. You must show where your results come from. You have to show the fundamental theorem, the calculus of it. And then 1 is for concluding correctly the absolute max is at x equal root pi, not giving the y value. Understood? So that's 3.012 or 3. And C. C is find the equation of a tangent line at x equal 2. What do you need to find a tangent line? A point, a slope, and then you write point slope, right? The points, they give you the x. Chances are, if you did that last one successfully, then you'll find the point successfully. How do I find f at 2? Plug it into the original f prime equation. That's for the slope. How do I find f at 2? Fundamental theorem. F at 0 plus change in f gives you f at 2. So, did you get something like 5.623? No?
Yes.
Oh. Okay. The slope. How do you find the slope? Slope comes from the derivative. They gave you the derivative, so you're just plugging 2 into the derivative equation. Negative 0.459. Yes? Wait. And so your tangent line equation would be something like y minus 5.623 equals negative 0.459 times x minus 2. That was 4 points. Wow, that's really generous. 4 points. 2 for finding f at 2. That blows my mind. They distributed the points the way they did. 2 for finding f at 2. 1 for finding the slope. By the way, if you don't communicate that the slope comes from the derivative, if you don't write that, if you just say m is, that doesn't get you the point. You must say the slope comes from the derivative, and then report the result, and then the line. Okay? Give yourself 0, 1, 2, 3, or 4 there. This one was worth 4. 2 for the point, f at 2. 1 for the slope, 1 for the line. Cool? So did you drop a 9? Who dropped a 9? Come on. Yes, that'll kill you. Why are you so shy, man? If you drop a 9, you shouldn't say, okay? Right, baby. Yes. Anyone have any questions? Just for the x equals 0 is at the end, so you should. That's fine. Yeah, no, you don't have to say it all. Say it.
Wait, it's only.
Yes. Okay. All right. Other questions on this blue sheet? I don't remember what is the back easy enough or not? 61.5?
Yeah.
Okay. 61.5. And 60 what? 62.4. Okay. Alrighty. 61.5 is given the derivative is root x plus 1 over e to the x f prime at 0 equals, oh, this is the second derivative, sorry. 3 f at 0 equals 4. Okie dokie. So, that second term is one of the great trap problems in calculus. Do you agree that I could anti-differentiate f double to get f prime? Yes? And if I anti-differentiate that, it's probably tempting to say 2/3 x to the 3/2 plus 1 over e to the x, yeah? That's not right at all. Yeah, so unfortunately, that's not e to the x. That's e to the negative x right there. Okay? That's x to the 1/2 plus e to the negative x. And that, being in the denominator, it matters. Whether you use sub it or not is up to you. If you go by the book and use sub it, this is, I think we're cool there. But if I do this by u sub, u is negative x, du is negative dx, so negative du equals dx. So this becomes e to the u times negative du. The antiderivative then is negative e to the negative x plus a first constant for f constant. So check that right there. Did you get a negative when you anti-differentiate? Are we cool? Okay, now use the initial condition here. If I use this initial condition at this point, that allows me to find C1. 3 is equal to 0 minus e to the 0 plus c. Common mistake also is to not evaluate that e to the 0 term and think it's 0, when in fact it is 1, so c is 4. C1 is 4, sorry. I'm about to get a new. Are we cool?
Yes.
All right. At that point, f prime is complete. F prime is 2/3, this should be 3/2, sorry. 2/3 x to the 3/2 minus e to the negative x plus 4. F then is the antiderivative of that. What is the antiderivative of 2/3 x to the 3/2? 2/3 I'll just float that. What's the antiderivative of x to the 3/2? 2/5 x to the 5/2. Now this, we could use sub it again, or we could just kind of use our noodle and say, hey, what happens when you anti-differentiate? You pick up a negative, right? Now if I pick up a new negative, what would the antiderivative of that be? Are you with me? Should I use sub it? Are you going to lose it, or what's the deal? What's the antiderivative of this, please? Negative, negative. So positive. E to the negative x plus 4x plus a new constant. Using that initial f condition, f at 0 equals 4. F at 0 equals 4 allows me to find C2. 0 plus e to the 0 plus 0 plus C2. C2 is 3. Therefore, f of x is 4/15 x to the 5/2 plus e to the negative x plus 4x plus 3. Okay? Does that make sense? All right. So I imagine that e to the negative x is probably the biggest problem here. The other one, the population density function. If you really were gutsy, you try this without your notes, but at the very minimum, I would expect you to probably use your notes. Um, there are some places, even with those notes, there are some places to fall down, so let's go over it. So you've got a lake here, and the radius is 1 mile. And you've got a density function that gives you density based on distance from the center of the lake. How many people live within 3 miles? So if I went from the lake edge to 3 miles out, I want to know how many people live in this area, yeah? Okay, now, this has a bit of a conceptual thing that you need to have down. I think you'll agree that you would have to take the density, which is in people per square mile, and in order to answer the question, to get how many people, you would have to multiply that by how many square miles, right? And accumulate all those many calculations because the density is constantly changing. So I definitely will need to integrate d of x, but the area. Now, I know it feels like the area is just, or sorry, this kind of dealio. The area of that region is just big circle minus little circle, right? Now the problem with that is that that density isn't the same for all that different regions. The density is different for every step out from the center you take. So the density here, just on this line, would be totally different than the density even 1 foot further away. And that would be different than 1 foot further away from that. And so I couldn't just do one big area calculation. I would have to do all of these little areas individually and multiply it by their little density just at that region individually. So that area really is the area of each line. Not the circles. And if you were to straighten that line, then it would have to do with the thickness being just the smallest thickness of change from the center, which is dx thick. How long is it? Circumference, or 2 pi r. Now r is x in this case. They said x represents the distance from the center. So that area would be 2 pi x dx. 2 pi x for the circumference and dx for the thickness. Then from 0 to, it says from 3 miles out. So is it from 0 to 3? It's not 0 to 3. It's starting 1 mile from the center and going out to 4. So it's not 0 to 3. It's 1 to 4. Okay. Down to the nearest person, I got 2,849 people. Other questions on this blue sheet? 66? 60.6? 60 number 6, okay. Okay. 60 number 6. All right. I handed back a hoard the other day. It was an area problem. I have a point built in on a test rubric for a graph. If it's something I feel like you should be able to, at this level, to graph, I should see a graph. There is absolutely zero reason to fly blind if you know what the graph looks like. You should be using the graph. So I would definitely expect a graph on each of these. You should, at this level, you should know that that first is a parabola with zeros at 3 and negative 4 and positive 3. Something like that. It's not very good. Negative x plus 3. If you can't graph that, just get out right now. All right, so I'm looking at a graph like that, yeah? Boom. All right, so the area calculation, it says the area, so I need to make sure I have rectangles with positive bases and heights. The area, it's one single region because it's always the same upper and the same lower, so I can do this in one interval. But right away, as soon as I start to write my integral, I don't know what the endpoints are. So how do I find those endpoints? The intersections. Set x squared plus x minus 12 equal to negative x plus 3. If I am generous, then I made it factorable, and I was generous. It does have zeros at -5 and +3. Do you agree? So the region bounds are -5 to +3. Now the heights, that's from an upper point on the line to a lower point on the curve. This distance then is upper minus lower. What's upper? Is it the line or the parabola? It's the line. So negative x plus 3 in parentheses minus lower. That's the parabola in parentheses x squared plus x minus 12. Yeah? All right, don't integrate 5 terms if you can integrate less. Let's combine like terms. I get negative x squared minus x is minus 2x. 3 minus -12 is plus 15. Do you agree? Okay, if I anti-differentiate, negative 1/3 x cubed minus x squared plus 15x from -5 to 3. When you put in 3, I get negative 27/3 minus 9 plus 45. When I put in -5, I get negative 125/3. No, positive 125/3, right? Because -5 cubed would be negative, but then I also have negative, so that's positive 125/3 plus, nope, slow down there, minus 25 minus 75. Check. All right. Now let's go with the thirds. Negative 27/3 minus 125/3 is negative 152/3. And then all the whole numbers. That's 36. 36 minus negative 100 is 36 plus 100. Are you tracking? 36 minus negative 100. I feel like that's good. 136 with the common denominator of 3. 136 times 3 is 408 over 3. 408 minus 156 is 252 over 3. If your answer that does divide. It goes into 252. How many times? 84 times. I got 256 over. Oh, it's because I cannot subtract. Sorry. This is 150. Oh, what the heck? Sorry, this is 152. So that's 256. That does not reduce. It's 256 over 3. So, I fell down right here. Yes? You could. It's fine. This actually, oh, no, it shouldn't be different. This should be negative 18 plus 45. You should get 27.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
It should come out the same.
All students, national junior, national junior, honor flag, military movement,
It's what?
Come celebrate the holiday season of the Buddhists.
Your arithmetic, it should be the same.
Second semester schedule will be released on Monday, December 17th. Counselors will be available for schedule changes after finals on Wednesday, December 19th, and Thursday, December 20th. Schedule changes are made for limited reasons.
Is there another question?
The wrong level of the class, not meeting the prerequisite of the class, visiting the main office for the sports mag. Please see Natalia or
58?
Sergio for a sport locker. The
59.8?
office is seen over
59.8 is that what you're talking about?
Bring your items to the locker room and not the
Dude,
main
very
office.
question.
Yes.
Thank you for your assistance.
I didn't, I just was.
NJHS meets today during 7th hour at the auditorium.
I wasn't here that day.
Junior high artists, if your work folder is on display in the library, would you please take it home before the winter break? Be sure to check out with Ms. James Heron and Ms. Porter so they know your sculpture is going home with the right person.
Okay.
Interact, hosting a Toys R Us for West
So
Gate
X-axis you get two regions, right?
Please bring pets and
Now,
dog toys.
if you know there's symmetry, then you can make it like these. No, now, if it was -2 to 2 and it didn't say anything about area, that would be 0. But it says find the total area, and you know there is area. So, if you know there's symmetry, then you could just find one and double it, and that would. You would have to prove the thought process is this is odd because these are both. Or you can prove that's odd and therefore symmetric. And so you could do 2 times the area from 0 to 1, and that works. If you couldn't prove it was odd or you weren't sure they were symmetric, then you would have to do 2. Okay? Now, if I did this guy, that's a negative area. If I use this one, it needs to be the opposite of that area, so something like 4x minus x cubed. To make that positive area, you have to negate the left values.
Today, your
And then you
team
just negate it.
against over 30 teams at the Chapta 4A state competition at the Denver Coliseum around 5 p.m.
This should be 0 to 2, not 0
Take
to
on
1.
rivals like Valor and Golden. Go Jags. That's all your announcements. Have a great day.
Okay, boom. So can I get the blue today?
Wait.
Still 2 behind. Someday we'll get caught up. No, we'll get caught up, baby. There's no chance. Oh, there's a chance. You think you're gonna die still not having gone over 63? Alright, make sure I get the blue by the end of the day, please. I guess you can, any questions on 63? You can just say it turned in.
I have some questions.
I have a lot.
I really didn't.
I hear all the knowing about your questions, and yes, we need to go see some tower. Actually, yes, it's just me now. But that's why Esther's killing it.
Hey, I'm trying.
All right, I'll take the blue only. All right, that's it. Hey, bye, Shiloh, if you're listening.